Chapter 1, Action on the Atmosphere, Control of Atmospheric Pollution. The demand for clean, pure air comes ultimately from the general public. It may come from a villager who realizes that the fumes coming out of a nearby industry are unpleasant to live with. It may be from a town or city dweller who finds that the industrial exhaust gases and vehicular exhaust contaminate the air that he breathes in. If people feel that the air they breathe is contaminated, they generate pressure to introduce legislation to control air pollution. In such a situation, the first question, what is the validity of such complaints? To answer this question, technical expertise and medical advice is required. The next question is concerned with the technical options available and the cost of adopting such solutions. Thus, the control of atmospheric pollution involves methods to reduce the existing level of pollution and develop strategies to avoid further increase in the level. Health and amenity. Identification of the problem. The World Health Organization defines health as a state of complete physical, mental and social well-being and not merely the absence of disease or infirmity. Therefore, clean air is considered to be a vital amenity. Air is said to be polluted when there is a disturbance in its natural composition due to the addition of harmful substances. The change will cause damage to the health of human beings, animals and plants. When we say air pollution is a loss of amenity, it means that the polluted air makes life less pleasant than it would otherwise be, with or without affecting health in the medical state. For example, excess of grit and dust deposit in a clean area undoubtedly creates a sense of displeasure among people, though it may not create a serious health problem. Similarly, unpleasant smell and diminution of sunshine can be said to be loss of amenity. Health is said to be damaged due to air pollution under three circumstances. First, an incident such as leakage of gas in a factory is followed by an increased rate of death or sickness, that is Bhopal gas tragedy. Second, presence of an industry in a town or city which emanates dangerous and poisonous emissions. And third, the industrial and otherwise activities which produce pollutants beyond acceptable levels. Air pollution limits to protect health. In view of the loss of amenity and the health hazard due to industrial and other atmospheric pollution, the World Health Organization has prescribed the following limits of air pollution. First is long-term goals. The WHO prescribed limits to air pollution in such a way that the maximum limit does not cause many ill effects in the long term. The air pollutants considered for limitations are sulfur oxide, suspended particles, carbon monoxide and photochemical oxidants. Second is short-term goals. The short-term goals are intended to prevent illness and death in the susceptible groups. The air pollutants considered for limitation are sulfur dioxide, smoke in the presence of sulfur dioxide, carbon monoxide, and the photochemical oxidants. However, the short-term goals will vary from country to country and also within any particular country. Third is special factors. Certain pollutants are highly poisonous. Maximum allowable concentration is prescribed for such pollutants emanating from different types of factories. These maximum permissible concentrations are based on exposing a healthy man for 8 hours to the pollutants for 5 days a week. However, the general public, both age young and the infirm, are exposed for 24 hours and 7 days a week. The standard for such a situation is more stringent. Economic factor. The ill effects arising out of air pollutants certainly have economic implications. However, since air pollution is widespread over towns and countryside, it is difficult to argue for a case of reduction of air pollution on economic grounds. However, in specific cases where it is found certain that a particular type of industry or industries cause demonstrable damage, it is possible to take action to reduce air pollution. For example, in the Netherlands, the hydrofluoric acid from fertilizer factories were found to cause extensive damage to crops of flowers. Flowers are a major revenue earner for the Netherlands. The government of the Netherlands immediately took action to reduce pollution from the factories. Technical methods for control of air pollutants. There has always been a conflict between the technology and the cost of controlling air pollutants. The available technology often is not being used because of very high cost. However, controlling of air pollutants necessarily call for use of some technology. Controlling grit, dust and smoke. Serious pollution from grit and dust often result from winds blowing over deserts or across fields without vegetation cover. They are also raised by heavy traffic on roads where they are allowed to accumulate. A considerable proportion of dust from industrial sources has its origin in bad housekeeping. Piles of fuels or other material used or produced by the factory left exposed to the wind in the root is the root cause for dust pollution. With proper attention and, no, and cost effective method, these air pollutants can be easily controlled. Most of grid pollution emanates from factories. Simple and costly equipments, namely a settling chamber, different types of cyclone arresters, large size back filter plant and electrostatic precipitator are used to reduce grid pollution. A well designed tall chimney also arrests grid pollution. The following illustration explains the various methods used to arrest grit, dust and smoke. First is cyclone separator. Now you just look at the figure 1.1. It shows that the incoming pattern of air form a vortex from which the particles are removed by centrifugal force and fall to the bottom where they are collected. It is effective for large particles more than 50 micrometers in diameter, but not for smaller one. The efficiency of this method varies from 50 to 70%. Now second is wet scrubber. In this method, the exhaust gas passes through spray of water which is very effectively remove particles. It also removes some gases. Efficiency of this system varies from 75 to 99%. The wastewater, however, often produce polluted water. Now third is fabric filters. Fabric filters are more effective in removing small particles. Exhaust gases are forced through bags of very fine cloth like mesh which are capable of capturing tiny particles. Removal efficiencies may be as high as 99%. These are widely used in cement, carbon block, clay and pharmaceutical plants. Next is electrostatic precipitator. Now in the next figure, figure 1.12 shows a typical electrostatic precipitator, and it is a most efficient device for removing particles. The incoming waste gases pass over high voltage electrodes giving particles an electric charge. Then they pass between oppositely charged collector plates which they are attracted. Vibration of the plates causes the collected matter to fall down into large bins. Thermal power plants using fossil fuels often use the electrostatic precipitator and achieve a removal of more than 99% of ash. Now you just take a look at the electrostatic precipitator to control air pollution in uh, industries. So you can see the diagram of this electrostatic precipitator. Now next method is activated carbon absorber. Removal of gaseous pollutants is a more difficult problem. either they may be absorbed or converted into less offensive substance. The wet scrubber is also effective in removing gaseous pollutants such as ammonia, hydrogen sulfide, hydrogen chloride, chlorine and hydrogen fluoride. Activated carbon is used to remove gaseous pollutants. It attracts thin layer of gases and vapors to its surface, leaving the carbon unchanged. Once the carbon is fully saturated with the collected pollutants, it can be regenerated quickly with a steam bath. It is very effective in removing hydrocarbons. Controlling gaseous pollutants. First is carbon monoxide. The main source of anthropogenic carbon monoxide is the internal combustion engine of motorized vehicles. Anthropogenic means human made, the made by human beings. Along with the carbon monoxide, other toxins are also simultaneously released. Therefore, when carbon monoxide reducing measure is introduced, the concentration of other toxicants is also increased, and this problem induced development of exhaust system reaction which convert carbon monoxide to carbon dioxide and water. The other approaches to reduce carbon monoxide emission include improvements to engine design, development of substitute fuels, and development of new power sources. However, none of these measures have proved entirely satisfactory. Hydrocarbons. Hydrocarbons from stationary sources like industrial are controlled by use of after-burning absorption and condensation. After burning ensures complete oxidation of the hydrocarbons to carbon dioxide. For absorption, a bed of activated carbon is used. More often, the recovered hydrocarbon is periodically used for cleaning the activated carbon bed using steam. Otherwise, they may be disposed of by oxidation as carbon dioxide and water. Is oxides of nitrogen. Most of the methods employed to reduce natural emission of nitrogen oxide involve modification of the combustion process involved. So, there are no technical means of preventing the emission of smoke from open fires. The only solution is to avoid open fires and resort to smokeless fuels. However, in the case of industries where fire is resorted to, the burning is maintained efficiently. In this case, smoke is produced only at the start, that too for short time. If smoke is produced in excess, it means that the plant is inefficiently operated and administrative action is required to modernize the plant. Next is sulfur dioxide, which is produced when coal, coke or oil is burned. So there are two distinct problems to be solved. One is to reduce the concentration of sulfur dioxide at the ground level. The second is to reduce the detrimental effect of sulfur dioxide on the environment. To reduce the ground level concentration, there are a number of methods. The simplest method would be to restrict the use of coal, coke or oil which produce the sulfur dioxide or low sulfur fuels of coal or oil. The sulfur content in coal is reduced to a greater extent by normal washing technique. It is also technically possible to remove and cover a proportion of the sulfur and reduce sulfur dioxide emission from the use of given amount of crude oil in oil refineries. The other method is to use properly erected chimney to adequate height and design for good dispersion of the exhaust from the industrial gases. In this way, it is possible to keep the ground level concentration of sulfur dioxide as low as possible. The chimney height requires is 200 to 250 meters in large power station. The Taj Mahal trapezium. The Taj Mahal, one of the wonders of the world, is at great risk of getting affected by the gaseous pollutant emitted from about 512 industries surrounding the Taj Mahal, the Mathura oil refinery located close to Agra, and it also said to be a major source of sulfur dioxide affecting the marble stones of Taj Mahal. the refinery, foundries and pit furnaces are all found to be the major source of pollution. There have been several proposals to relocate all the 104 highly polluting industries from the Taj Mahal trapezium, which extends to an area of 10400 square kilometer, and also for the creation of green belt around the Taj Mahal. The Mathura on its part has set in motion several programs to reduce the sulfur dioxide emission. The refinery reported the following programs, and these are the programs reported by the Mathura oil refinery. Use of only low sulfur fuel oil in its furnaces and boiler, installation of sulfur recovery units and continuous improvement in its efficiency, state of the art instrument for emission control and monitoring devices, and continued thrust on energy conservation measures. Due to all the said measures, the sulfur dioxide emission level will reportedly be 500 kilogram per hour, which is much below the stipulated limit of 700 kilogram per hour. So, however, a combination of all the measures is found to be essential to save Taj Mahal from pollution. Malodorous emission from the offensive trade. Perhaps the most unpleasant form of air pollution are those which emanates from small establishment processing animal waste, food residues, etc. Intensive farming units also cause pollution over small area. In such cases, strict insistence on high standard of housekeeping and by using a proper design processing plants, the malodorous gases are contained as far as possible by passing the odorous gas through scrubbers or absorbers. Other methods of controlling air pollution, and in this penalties and subsidies. So it has long been felt that those who are polluting the air should be made to pay for doing so. In this case, the wrong becomes right by paying the price for it, and the ill effects of pollution are not reduced. Instead of this practice, it may have very good effect if all the pollution causing industries are shown subsidies in the form of reduction in taxes or other forms of concession if the industries fit pollution control devices and reduce pollution levels. Meteorological control. In any area, if the balance between emission of pollutants from industries and dissipation of the pollution is maintained, then there would be least chances of inconvenience to the people of the town. However, the meteorological conditions are not favorable. Warning may be given to those suffering from bronchitis to stay indoor, as normally the pollution level indoors is less. Planning permission for industrial works. Location of an air polluting industry is very important. A planning authority of the town or city should have land use development rules to control and regulate all new developments, particularly obnoxious and hazardous industries. The rules should also encompass not only larger major amenities but also the smallest workshop engaged in the offensive trade, namely processing animal waste, slaughter, etc. It is desirable to sanction permission to obnoxious industries far away from the residential area. With the modern transport facilities, commuting to the industries located at a far away distance is not a serious problem. Large scale industries activities need to be permitted only at locations identified to be safe from meteorological considerations. Town and country planning. The ill of air pollution are the outcome of lack of attention paid to the developments. The industrial sector should be separated from the residential area by a buffer zone or wooded area or gardens. Such zones absorb the pollutants to a great extent. With the careful planning, a major portion of long distance traffic which has nothing to do with the area under consideration can be diverted. By doing so, air pollution can be reduced significantly. Pollution from motor transport. Motor transport vehicles are mobile, that is non-point sources of pollution. A major share of air pollution in urban area is contributed by vehicular exhaust. Pollution from this source becomes significant only under congested urban conditions where there is a high traffic density. Two types of pollution can arise from motor traffic. One is the pollution by lead and the products of fuel combustion. Now, tetraethyl lead is added to petrol to improve its combustion characteristics and increase the efficiency of the engine. Most of this lead is emitted as lead oxide dust in exhaust gases, and some of it becomes airborne. The dust can enter the lungs where it is absorbed into the body and affects the bones. Many countries have taken steps to reduce the lead addition. Recently, in the year of 1995, lead-free petrol has been introduced only in metropolitical cities, only in metro cities on a limited scale. The vehicle manufacturers were directed to manufacture engine and suitable catalytic converter to enable uses of lead-free petrol. However, before introducing such a measure, it is important to understand two significant factors. One is that the engine will lose its efficiency because of low compression ratio if lead is not added to the fuel. Low compression ratio will necessitate more uses of fuel for the given power output. The second factor is the refining of petrol to produce high octane petrol without the use of lead. In this case, not only the cost is increased, but also more crude oil is also used. The most important danger is a high octane petrol will emit more hydrocarbons which are carcinogenic, that is the cancer causing in nature. Methods of emission control. Emission control is carried out by three different methods, namely vehicle emission control technology, alternative fuel and technology, traffic management and policy instruments. Now, vehicle emission control technology. Technological innovations are applied at the source of emission, namely the engine itself, to bring down the level of emission. The engine design itself is modified for more efficient burning of fuel and less emission. Second is alternative fuels and additives. The characteristics of alternative fuels vary significantly with respect to engine design and performance and exhaust pollution. Hydrogen, methane and methanol burn efficiently and are low polluting fuels. Hydrogen, furthermore, does not produce carbon dioxide as a product of combustion and therefore does not contribute to greenhouse effect. Others such as vegetable oils have poorer combustion quality compared to petrochemical fuels and their emissions must be carefully controlled. CNG, that is compressed natural gas. According to the World Bank report 1990 and automotive air pollution, it is estimated that the use of CNG would reduce hydrocarbon emission by 40% in the exhaust and completely eliminate hydrocarbon emission through evaporation, and at the same time carbon monoxide emission would be reduced by about 50%. However, the oxides of nitrogen will not be as high as 40% and could be further reduced with improvement in emission control. Thus, it is considered CNG reduces considerably the carbon monoxide tropospheric ozone. The greenhouse effect is minimized. Alcohol. Exhaust emissions from neat alcohol engines have fewer components compared to gasoline or diesel fuels. Engine design for neat methanol tend to have low emission of carbon monoxide and other oxides of nitrogen and unburned fuel. Evaporative emissions are also low. Methanol is also expected to significantly reduce the reactivity of exhaust, thus reducing the ozone level. Alternative fuels are estimated to reduce carbon monoxide emission considerably. Now, traffic management and policy instrument. Effective management of traffic without delays and smooth movement would considerably reduce air pollution. Instead of too many and different types of vehicles, mass transport with higher capacity and lower pollution need to be encouraged. Public transport options. Public transport options that could be considered in the context of an environmentally sound urban transport system include building new public transport facilities, major overhaul and improvement of the existing transit lines, effective bus and rail transit fleet operation and maintenance programs, use of clean fuels or buses and taxis, electrification of commuter rail lines and provision of exclusive roadways for non-motorized mode, that is bicycle rickshaw. Traffic management measures aim to improve traffic circulation can result in substantial fuel saving and reduce emissions. They include a wide range of measures such as signalization and intersection improvements, including use of computerized area-wise traffic control, prohibition of turning movements to maintain smooth flow of traffic, use of one-way street pairs and reversible lanes, designation of special lanes or exclusive facilities for buses and other high occupancy vehicles, that is HOV, segregation of motorized and non-motorized traffic through provision of exclusive facilities for pedestrians, bicycle and human and animal drawn vehicles, designation of truck routes, time and space restriction on urban goods movement, use of staggered work hours, parking control and restrictions and restricting vehicles entering into congested inner city area. Economic policy measures to control motor vehicle air pollution. Economic policy instruments used to bring about a reduction in motor vehicle air pollution commonly consist of market incentives to influence consumer behavior. These measures promise to be effective in reducing air pollution while increasing the efficiency of road transport, and they include different taxation for leaded and unleaded petrol to promote the use of unleaded fuel. Fuel price surcharges based on the lead content of petrol or the sulfur heavy oil content of diesel to encourage refiners to produce clean fuel. Low taxes on clean fuels such as compressed natural gas and alcohol to encourage use of cleaner alternative fuels. Lower duties and taxes on fuel efficient vehicles. Lower duties and taxes on purchase of low polluting vehicles to offset the cost of emission control and to promote the sale of such vehicles. Higher license fee and taxes on older and non-conforming vehicles and other tax incentives to scrap older polluting vehicles. Taxes to restrain the ownership and use of private automobile, particularly the gas guzzlers. Tax deduction for vehicles with the emission control devices or to modify vehicles to run on cleaner fuels. Mandatory use of low or non-polluting vehicles in government fleet to expand the market for such vehicles and reducing manufacturing cost. Import ban on non-conforming used and reconditioned vehicles and vehicles above a specified age, that is 5 years. Taxes on CFC based air conditioning system in automobile, buses and trucks, and concession for installing non-CFC based systems. Taxing businesses and employers to help pay the transit cost of employees. Taxing employees benefits such as free parking, company vehicles and fuel allowances with such benefits treated as income. The economics of alternative fuels. The economics of alternative fuels depends on the cost of production and the additional cost of storage distribution at the user end. Production costs are a function of abundance or scarcity of the resources from which the fuel is produced, as well as technology available to extract those resources. The additional cost of storage, distribution and end vehicle use is important since petrol and diesel fuel made from heavy oil or natural gas require relatively minor changes to existing distribution and end use system, whereas CNG and alcohol fuels require major modifications. Economic considerations for developing countries to make a serious commitment of resources to combat air pollution, economic impacts of the environmental pollution have to be much greater than the cost of abatement. Only if it can be clearly demonstrated that environmental pollution is in fact a serious drag on the economy, including the damaging effect on health and public welfare, can major ameliorative actions be expected. There is a wide variation among developing countries in the severity of the impact of air pollution, that is health effect, acid deposition, deterioration of lakes and forests and so on, in the assimilative capacity of the atmosphere, in public attitude, in degrees of urbanization, in transportation system and in economic conditions. Consequently, the policies and their methods of implementation will also vary along with the urgency for tightening air pollution standards and pursuing attendant strategies. The basic issue is represented by the question, what strategy should be adopted? How soon and at what cost? The answer to this question can be approached by accessing the marginal cost of allowing the emission of given quantity versus the marginal cost of abating the amount of air pollution. The optimal approach to pollution abatement programs and timing of implementation should be to select the strategy that equates the two marginal cost. Some of the financing options for air pollution abatement programs include mobilization of funding from the private sector, joint property developments, different levels of taxation schemes, and various tax concession and public bonds. Cost and effectiveness of alternative strategies. A careful cost-effective analysis would be necessary before a particular set of strategies is adopted. Environmental problems related to land transport vary in severity from country to country depending on geography, climate, social and economic conditions, infrastructure facilities and resource ability. Appropriate solution will therefore depend on overall priorities set by the countries concerned and their determination to tackle specific environmental problems. The cost effectiveness of the various control measures should account for the full range of related factors such as energy and technological development, impact on public and private expenditure, and on cost of living. Balance and compromises among conflicting objectives may be required in the evaluation depending on the priorities adopted. A major obstacle in choosing cost-effective options to combat transport-related air pollution is the paucity of information on the cost of various control measures and their effectiveness. Urgent need for action. Pollution of the atmosphere affects the lives of millions of people in all parts of the world, especially those living in large industrialized cities with heavy motor traffic are the most affected. The ill effects are unpleasant fumes and odors, reduced visibility, injury to human health and crops and other forms of vegetation, damage to property by dust and corrosive gases, Most people are willing to accept some environmental deterioration in exchange for a higher standard of living and a greater abundance of consumer goods. But as living standards rise, man-made air pollution is seen first as a major irritation and then as a threat to the quality of life. Excessive pollution can jeopardize health, and certain type of pollution may even render some areas unfit for normal habitation. It is therefore a serious obstacle to socio-economic development. Thus, many national, regional and city administrations now face an increasing public demand for the control and abatement of air pollution. A specific assessment of air quality and its capacity to assimilate pollutants for safeguarding the atmosphere should form the basis of a national air quality management program. A number of events in Europe and the United States have made the people aware of the adverse effects of air pollution. Though in India, laws have been enacted to control air pollution, the enforcement is yet to become effective. Remedial action in phases makes identification of the problems related to air pollution at regional and local level imperative. Approaches to legislation. There can be three different approaches to the legal problems related to environmental protection. Air pollution control is one part. The first is characterized by legislation which limited objectives. Each law is concerned with a single aspect of environmental protection or pollution. In this traditional approach, air pollution forms the subject of a set of laws. The second approach is of a major comprehensive character. One law regulates activities that may cause environmental damage through effluents released into the air and water or nuisance such as noise. The Swedish Environmental Protection Act is an example of this approach. The third consists of integration of environmental legislation with the town and country planning and national planning in general. And this legislative approach chosen by Yugoslavia ensures integrated treatment for both country and urban environment. Elements of air pollution legislation. The development of air pollution control legislation is largely a problem of the specialized application of accepted principles of administrative law. In most countries, the central government frames general laws and often leaves the details to administrations. Basic acts are supplemented by ordinance which should be reasonably specific but provide adequate flexibility to meet the needs. Even if the air pollution control policy is the same, legislation will vary from country to country owing to differences in administrative and legislative traditions. Legislation and administration are means of realizing the air pollution control strategy. Therefore, legislation has to be framed so that it is an effective instrument for carrying out this strategy. The principal features of the air pollution control strategy should be decided on before the legislation and its administrative machinery given the final shape. The preparation of an air pollution control strategy include the setting of goals, second the formulation of plans for attaining these goals, and the introduction of a system of supervision. The long range goals can only be defined in a very general way, and they have to be broken down into realistic short range goals that can be effectively met in a reasonable period, say 5 years. The elements to be used for reaching the goals are discussed below. Now the first is permits, registration and general provisions. Air pollution may be regulated differently according to the nature of the source. The sources are new and existing stationary sources that individually contribute significantly to air pollution, new and existing stationary sources that individually contribute less significantly to air pollution but which are built in large numbers, motor vehicles, aircrafts, and mass-produced fuel-burning appliances. The most effective way to control air pollution from stationary sources is a permit system under which prior approval of plans, signification, and other data for new constructions or alteration is required. Approval is given only if the control to be provided are, in the judgment of the agency, adequate to meet the air quality and emission requirement. Central level agency. The function of a central level agency are advise the government in air pollution, on air control policies, particularly in relation to industrial production, energy conversion, transportation, waste disposal, and urban planning. Work out and propose the government air quality and emissions standards that may be applicable on nationwide scale. Designate air quality control regions and approve implementation plans for such regions. Review periodically the list of categories of stationary sources that should be covered by a permit or registration system and publish manuals and codes of practice for these sources. Administer the permit system for stationary sources that individually contribute significantly to air pollution and for which the sitting is of national interest or for which expertise is not available at the regional or local level. Set up or designate a laboratory to act as a national center for testing analytical and sampling techniques, calibrating measurement equipment and training personnel in the use of the relevant techniques and equipments. Support, coordinate and run research and development projects in accordance with the administrative needs for knowledge and information. Conduct public information programs and publish annual reports on its activities. The authority of the general agency may vary depending on high-level administrative arrangements. In one country, for instance, the central agency may be authorized to establish national air quality and emission standard, but in other only to develop and propose such standards, leaving their adoption to the government. Regional level agencies. The functions of a regional level agencies are adopt and submit implementation plans for air quality control regions, exercise responsibility for control of the larger and more complex air pollution sources through a permit or registration system and periodic inspections, develop a register of air pollution sources in the region, emissions from them, degree of emission control and related data. Establish networks for air quality measurements and warning system and carry out measurements in accordance with administrative needs. Study plans in existence or being made for transportation, energy supply, waste disposal, land use, provision of open space, etc. for the purpose of coordinating the plans with the air pollution control work. Provide technical assistance and guidelines to local agencies. Local level agencies. The functions of a local level agencies are exercise responsibility for the control of air pollution sources that are not covered by permit or registration system. Generally, they are run by regional or central agencies. Exercise control of smoke from small combustion operations, open burning and abatement of nuisance from small industries and commercial establishment. Carry out the routine surveillance of sources and the necessary air quality monitoring programs. Investigate public complaints and detect violation of regulation. Finally, it should be stressed that air pollution control cannot be accomplished without close cooperation among all levels of governments, industries and public. Clear definition of the responsibilities of the various level will facilitate such operations. Now coming to the legislative control of air pollution in selected countries. So in England, as you can see, in England, the Clean Air Act of 1956 gave officials to the authority to curtail industrial emission and to restrict domestic heating to smokeless fuels. Coal smoke was dramatically reduced and London today is a far cleaner city. And in United States, a federal level in United States of America, air pollution legislation was introduced in 1955, but this only provided for research and technical assistance to state and local government. The first and important national legislation was the Clean Air Act of 1963. In India, the real awareness about environmental protection at global level as well as in India was created in the Conference on Human Environment held at Stockholm, Sweden in June 1972. The late Prime Minister Indira Gandhi took keen interest and initiated appropriate steps for the protection and improvement of environment. The Air Prevention and Control of Pollution Act 1981 was promulgated on 16th May 1981. The Central Board for Prevention and Control of Water Pollution was entrusted with the responsibility of air pollution control also. The Central State Board of Water Pollution Prevention and Control, established in 1974, was amended in 1988. And the Central State Boards were renamed as Central State Pollution Control Board. The Central Pollution Control Board (CPCB) and the State Pollution Control Board (SPCB) advise the respective ministries on the problem of pollution. The Air Prevention and Control of Pollution Act 1981 and the Motor Vehicle Act 1988 provide for prevention and control of air pollution arising out of industries and motor vehicle respectively. The motor vehicles are to be subjected to an emission test effective from 1989 to satisfy the following: idling emission limit for four-wheeler petrol driven vehicles shall not exceed 3% by volume. Idling emission limit for two-wheeler and three-wheeler petrol driven vehicles shall not exceed 4 to 5% by volume, and smoke density for all diesel driven vehicles shall be, and here you can see the table where there is a maximum smoke density, limit of the maximum smoke density is given. Environment and development. Environment and development are the two sides of a coin. The debate on these two aspects has assumed global, national and local importance. The view of developed countries has so far been that man is superior and controller of nature. The view induced exploitation of nature to produce more and more goods for consumption. The pursuit of this approach to development lead to exploitation of nature to an extreme limit. The result is the fear of the very survival of human race. Till recently, the question has been whether to have development ignoring environment or preserve environment by stopping developments, but it is soon realized that development is highly essential. The march of civilization from that of barbarism to the modernism is due to the development and growth. Therefore, stopping development is not the solution to the problem. The emphasis is to have developments by preserving environment, ecology and biodiversity to a warranted level. However, it has not been easy to resolve this issue to a satisfactory level. The reason is that since environmental safeguard is also a global issue, both the developed and developing countries have their own views. The common grounds, development and environment, and the released issues are the common interest to both developed and developing countries. It is an accepted fact that economic development and sound environmental management complement each other. Development itself contributes to environmental regeneration and rejuvenation. On the other hand, a healthy environment is a necessary condition for sustainable development. There is widespread realization that over 1 billion people around the world are in abject poverty. The next generation will therefore see the world population rising by 3.5 billion. The most fearsome aspect of this population increase is that the most of these births will be in poorer families. Therefore, alleviating poverty is not only the moral responsibility of the present generation but also necessary condition for environmental sustainability of this earth. It is highly essential that the earth is left intact for the welfare of the future generation. It is also a fact that no country has so far eliminated poverty without economic growth, but the economic growth itself has often been the cause for serious environmental damage, threatening the present and future quality of life. The solution to the problem of poverty and environment need not to be producing less. It lies in producing differently. Thereby, economic growth is made sustainable. Economic growth is essential for progress in developing countries. At the same time, it should not be at the cost of polluting air, water, destroying extensive forest area and depleting all unnatural resources. Often, it is found that economic growth in real terms may be far less than the cost of restoring the lost environment. In many cases, environmental damage is irreversible. Therefore, efficient use of all resources becomes absolutely necessary. Thus, large-scale renewable resources are required. It is also needs it also needs support of technologies which are environment friendly. It is there that divergence between the northern and southern view of environmental problems and development perspective starts. The view of developed, that is north countries. Developed countries point out the problem of developing countries are essentially related to productivity. The health risks arising out of air pollution is very serious dimension. It is pointed that due to indoor air pollution from burning wood, charcoal or animal dung, the health of 400 to 700 million people is endangered. Dust and soot in city air causes premature death between 3 lakh and 7 lakh per annum. Tropical forest, the primary source of livelihood for about 140 million people, are being lost at the rate of 0.9% per annum. It is indicated by the north that with the present rate of energy utilization by industries in developing countries, emission from fossil fuel would increase to tenfold. The north suggests that developing countries must adopt low waste and clean technologies to reduce carbon emission. The subsidies offered to the poor sector and vehicle fuel should be eliminated to reduce pollution. Policies to reduce pollution directly using economic incentive laws and regulations are also advocated to reduce the effects of global warming. The North strongly emphasizes that uncontrolled population growth in developing countries is the major cause for environmental degradation. Population growth increases presence on all sectors to increase output, which in turn increases the pollution. Thus, it is suggested that the urgent and effective population control is the prerequisite for environmental protection. The views of developing, that is the South countries, developing countries express their dissatisfaction over the views of North or developed countries. The developed countries views that the high population growth is a major cause for environmental degradation, which is disputed by the South on two grounds. One, the environmental impact of population growth in the high income developed countries far outstripped the impact of population growth in the low income developing countries. It is assessed that 9,000 out of every 10,000 births in the world would occur in the next decade in the developing countries, but every 1,000 babies born in the developed industrialized world consume 3 to 4 times as much of the earth's resources as 9,000 born in the developing world. It also means that every 1,000 babies born in the developed countries in the north impose on earth's carrying capacity a burden equivalent to that imposed by 36,000 babies born in the developing countries of the south. It is therefore argued by the South that the North must reduce the level of consumption while the South contain the population growth. The South argues that the North should also realize its contribution to the environmental degradation and take appropriate measures to reduce it. The second aspect is the contention of the North that deforestation of tropical forest is because of high population growth and extension of agricultural activities. The South feels that the high rate of deforestation is because of the debt servicing necessity and the high demand for forest product from developed countries. Very good example of to this highlight the debt servicing trap is a project supported financially by World Bank and IMF combined in Brazil and Indonesia. Iron ore projects in Rondônia and Brazil and a dam project entail deforestation of areas twice the size of Britain and an area equal to that of France taken together. The financial assistance that is extended by the financial institutions like World Bank and International Monetary Fund of the North is based on two terms. One, the borrowing countries can sell the wood to the developed countries initially and then obtain a financial loan to reforest and repair the environmental damage. But to pay back the loan, invariably more forest area is clean. Thus, the North not only gets the interest but also export orders. Primary resources for 73% of their export earning is carried out by developing countries. Thus, the experts in the South feel that it is nothing but underselling. In international markets, the manufactured goods from the developing countries are always sold at low prices, whereas oil and other imports from the developing from the north have always been escalating. To fill up the shortfall in international market prices, exports are increased by increasing land under export crops. This gain results not only in increased deforestation for cultivation but also excess production, further reducing prices in international market. The contention of South is that the more important question of global warming and its consequences are ignored by the North. Production of carbon dioxide and other emission by burning of fossil fuel is the highest in the North, and the North is silent about these issues. For example, when compared to all developing countries together, United States alone consumes a major share of the world's transport energy. It is estimated that all developing countries together contribute about 4% of the global emission of fossil carbon dioxide. On the contrary, developed countries contribute more than 18%. The South argues that some of the major environmental damages are mining of the earth, nuclear testing by the North, mismanagement of nuclear waste, and dismantling the military apparatus. The South feels that the greatest harm to the environment is the expanding activities of multinational corporations. Bhopal gas tragedy is the good example of such a major environmental injury inflicted by the multinational company Union Carbide Company. The unfair international trade practice of the North is considered to be one of the major causes standing against both poverty alleviation and environmental protection in developing countries. Role of multinationals. The primary objectives of multinational corporation is to maximize profit by exploiting the resources of developing countries. At the same time, they pay very little attention to the environmental problems arising out of their activities in developing countries. Multinationals have repeatedly exported banned drugs, pesticides, and even entire factories to developing countries. For example, it is established that asbestos today is the largest single cause of occupational cancer. In United States alone, 8,000 to 10,000 are estimated to die of asbestos pollution. Use of asbestos in industrialized countries like Britain and US has come down drastically. Sweden has virtually eliminated the use of asbestos. In Ahmedabad, Shri Digvijay Cement produces 50,000 tons of asbestos cement pipes and sheets per year. Its foreign collaborator John Manville Corporation has so heavily sued the US that it took refuge under bankruptcy laws. In Bombay, Hindustan Ferrado, in collaboration with the British company Turner and Newall, manufacture asbestos textiles and brake lining, which are being abundant in Europe and USA. No attempt has been made by these companies to inform Indian workers or consumers of the dangers of asbestos. The Bhopal gas tragedy was the outcome of leakage of lethal gas methyl isocyanate from the pesticides manufacturing industries called Union Carbide Company. This mega tragedy which caused death and physical damage to thousands of people raised series of issues about the role of multinational company and environmental protection. The following are the issues and measures put forward for future guidance in establishing the role of multinationals. Adequacy of air and water pollution control and laws, strict enforcement similar to what is practiced in France. All companies and installations which can pose a danger to the environment have to get themselves registered by law. Location of hazardous industries away from populated area and creation of green area for about 12 to 30 square kilometer around such industries. The companies are to be made responsible to maintain the green area. A number of pesticides and drugs which are banned or restricted in advanced countries are imported or manufactured in India. For example, PCBs, that is polychlorinated biphenyl, used in electrical capacitors and transformers, are banned in advanced countries because they produce cancer. In many small scale industries where the chemicals are used, workers are not even aware of the danger. Therefore, the full environmental implications of particular industry should be clearly made known before its establishment. The choice of technology is another major concern. Uses of obsolete or banned manufacturing process by multinational pose serious danger to the environment. Industries from multinational should be screened thoroughly before permitting them to establish their industry. Transport of toxic chemicals by multinational without adhering to proper safeguard to another major source for concern. For example, Union Carbide Corporation transported MIC to several locations in India without any regulations, whereas Transport of chemicals like MIC in USA can be done only after satisfying all safeguards. Multinational companies should be made to adhere strictly to the safety regulations in developing countries. Remote sensing satellite. Satellite remote sensing developed from airborne remote sensing in 1960s and 1970s. Satellite remote sensing is the use of sensors to collect information about Earth atmosphere, ocean, land and the ice surfaces. Commonly, the information is collected in two-dimensional from either as a photographic image or as an array of digital data. Remote sensing satellite orbit the Earth at a variety of altitudes. The sensors mounted on satellites gather electromagnetic energy reflected, emitted or backscattered from part of the Earth atmosphere system below the satellite. The basic questions are: why has this data exploration, why this data explosion taken place in satellite remote sensing, and why does satellite remote sensing provide a useful source of environmental information? The following are the reasons. Data coverage. Satellite remote sensing allows data collection in remote land, ocean and ice area. Otherwise, the vital data may not be able to collect it because of the restricted accessibility or political regions. Data collection is greatly improved and complete when compared to conventional method. Homogeneity. Information collected by any one satellite system uses one sensor and so provides spatially consistent data. This is in direct contrast to the several methods used in ground data collection. Spatial continuity. Satellite remote sensing data are spatially continuous compared to the point or small area sample data commonly found in meteorological, oceanography and geology. Satellite remote sensing provides the best quality large area coverage database on the Earth yet in existence. Computer processing. Satellite remote sensors produce digital data which are in form of suitable for direct computer processing. In fact, the vast quantities of data produced by satellite remote sensing demand rapid computer processing. Frequency of data collection. The frequency of data collection is greatly improved using satellite remote sensing. For example, the geostationary weather satellites scan a disk of the Earth every 30 minutes. Polar orbiting weather satellites collect data twice per day for each part of the Earth, and land satellites pass over the same point on the Earth every 16 days. Less time base. The less time base or speed with which the images are covered is so fast, variation in environmental changes is very much minimized. For example, the Landsat thematic mapper images a scene of 170 km into 185 km in just 25.87 seconds. Complementarity. Measurement from satellites are complementary to conventional observation. Satellite remote sensing eliminates the need for ground check at a huge cost and time. Low cost means the computer compatibility of satellite remote sensing data allows reduction in the time and manpower required to produce environmental survey information. Environmental applications of satellite remote sensing require processing of data into derivative products such as maps of land use, geology or water and atmospheric pollution, so that the extensive body of radiance data collected by satellite can be used to achieve their potential. Satellite and ecological changes. Rapid ecological changes occur as a result of the neglect and misuse of environment through anthropogenic manipulation. Today, environmental protection has become a global issue. because the very existence of human race is at threat. Environmental crisis occurs due to extensive deforestation, land degradation, flood, siltation of river, pollution of air and water, drought and shortage of drinking water, urbanization, indiscriminate industrialization. A proper assessment of the siltation is necessary before any serious effort to restore the imbalance can be made. Satellite remote sensing is a powerful tool which can reveal clearly the factors causing environmental degradation. It enables periodic and accurate monitoring of the state, growth and productivity of all changing or seasonal phenomena. Thus, it can provide detailed information on crops, water resources, vegetation, status, and the environment. This technology has immense relevance in the areas of deforestation, desertification, land degradation, floods, and river management, and drought and cyclone damage. Satellite and application. Deforestation. In most developing countries, forests are being destroyed at a rapid rate, posing a threat to the economy and ecology. It is estimated that tropical forests cover only 7% of the Earth's surface. Within this 7% of Earth's surface, 70% of the planet's species are housed. If deforestation continues at present rate of 7.5 million hectare per year, forest resources will be reduced by about 40% by the year 2000 in the third world countries. Besides aggravating poverty, this will induce environmental problems such as soil erosion, soil moisture loss, siltation, heavy runoff resulting in irreversible and large-scale climate changes. Now, satellite-based forest cover studies have been implemented. This helps conservation plans and the check unplanned deforestation. Satellite data is also used to monitor changes at the micro level. Desertification is also a worldwide phenomena. It is gradually decreasing the natural resources of land. It is estimated that 230 million people the world over directly threatened. It is estimated that 3.5 billion hectares, including about 17 million hectares of irrigated farm land and 173 million hectares of croplands are prone to desertification. Desertification ultimately leads to strong disturbance of the natural equilibrium reflected by sphere vegetation and changes in pedological, that is the soil pattern and surface water imbalance. The immediate cause for expansion of deserts are overgrazing, felling of trees, waterlogging, salinization and bad agricultural practices. Space-based imageries, that is photographs, have made it possible to take advanced action to halve the advance of the desert. Land degradation. Satellite imageries have made it possible to identify degraded land. Land degradation occurs due to its location, environment, chemical and physical properties of the soil. Identification of such lands and bringing them under vegetation of great importance to developing countries. Waste lands. Waste lands include highly saline soil. It is caused due to increased use of fertilizer and improper irrigation practices, deforested area, degraded land area affected by periodic partial deforestation called zooming and other practices. Satellite imageries made it possible to provide finely information for taking immediate corrective measures. Floods. It is an annual feature in many developing countries. The damage caused is manifold, and to access this for taking appropriate measurement or control measures. It is essential to map the flooded area and to identify flood prone areas. Satellite data is ideally suited for this. For example, in Bangladesh, flood caused inundation of 2.4 million hectares in 1998. it was possible to assess the extent of damage to crop and take timely action due to the information provided by the Landsat and IRS 1A. Droughts. If excess rain brings misery, the lack of it can be equally disastrous. Periodic use of vegetation index obtained by satellite imaging has now come to be recognized as most reliable for monitoring agricultural drought. Assessment of drought condition is done by using supplementary information of rainfall and surface water condition. These studies are leading to a national level system for drought assessment and early warning using satellite data. Mining. Several environmental degradation is caused by intense mining activity. Remote sensing technologies are now used regularly to access the damage. Satellite data can also be used to map active and abundant mines. Ozone depletion. Satellite measurements made over Antarctica during 1970 to 1983 revealed significant ozone depletion. Further studies have confirmed that the decrease is due to the increased concentration of atmospheric chlorofluorocarbons. In other satellite-based observation on global distribution of surface skin temperature changes from 1979 to 1982 showed areas having excess of CFC over some of the countries or continents. These observations can provide a greater insight into the effect on global climate for developing suitable mathematical models for weather prediction. Space technology offers a powerful and speedy means to tackle some of the urgent environmental problems. International action for a new corporation to deal with ozone depletion. Need for North-South cooperation. Earth's deteriorating atmosphere is only one of the several environmental problems. Continuing ozone depletion and climate change is a serious threat to the very survival of the human race on Earth. There is adequate and compelling evidence available to prove that continued depletion of ozone is taking place. Since it is a global problem, it is imperative that both North and South join together to mitigate the problem. Now you can see in this figure there is a relationship between earth warming, destruction of ozone layer, and this is the increasing global environmental destruction. The efforts must include all the issues relating to international trade and debt, development and assistance, energy technology transfer and population. Considering the speed and the extent to which ozone is getting depleted, it is important that all nations in the world should move quickly towards arresting further depletion. This is because of the fact that even if all activities responsible for depletion of ozone are stopped, it is unlikely to restore the ozone to its original level within a short time. Who is responsible? The vast quantity of air pollutants lodged in the atmosphere over the past century can be traced mostly to the industrial north. It is because of extensive use of fossil fuel and industrial chemicals. But in recent times, the contribution from the south is also increasing. It is because of the extensive deforestation of tropical forest and changes in land uses. Combined together, they contribute about 1/3 of carbon dioxide that human activities produce each year. Raising cattle, growing rice, and producing oil account for much of methane. From all sources, the developing countries contribute about 40% of each year's greenhouse gas toll. The share is likely to increase with the increase in population and industrialization. Therefore, if global warming is to be contained within tolerable limits, both the North and the South will need to adopt energy, forestry, population and agricultural strategies consistent with that end. Ozone depletion and implications. According to US Environmental Protection Agency, if all emissions of chlorofluorocarbons CFCs are stopped, it would take 60 years for atmospheric chlorine to return to 1985 level. It is also a fact that no one really knows how long it will take to discover positive proof that the Earth's climate is changing. How much change may already be in store. However, it is strongly viewed in scientific quarters that there may be some nasty surprises ahead. The ozone hole over Antarctica was such a surprise that scientists at first missed it altogether. Further, the British scientists who eventually discovered the ozone hole in 1982 did not publish their discovery until 1985, because it was so incredible that they wanted to verify it first. When the result finally got out, it made a serious impact on the international scientific world. In 1987, the protocol held at Montreal discussed the problem at length, but the decision to curb the ozone depletion really took effect only in 1989. By that time, it was already late. Way back in 1986 itself, new research findings continually showed that the ozone layer was thinning faster than suspected. It was estimated that the ozone layer over the northern hemisphere has declined 3% since 1969. The impact is that for every 1% ozone loss, there is an increase of 2% of ground level ultraviolet radiation. Now, international efforts to prevent damage due to ozone depletion. It is assessed that the ozone depleting molecules, it takes nearly a decade to drift up to the stratosphere. Therefore, the present damage is due to the emissions occurred during 80s. It is also estimated that chlorine atoms are responsible for the ozone depletion. The chlorine atoms kept destroying stratosphere ozone for 75 to 150 years. These findings establish the fact that even if all chemical emissions are stopped, the ozone depletion will continue for many years to come. The industrial north is responsible for most ozone depleting emissions so far. Therefore, it is only reasonable that the industrialized countries, which are sound financially and technologically, should help developing countries to increase the standard for living. For example, only 1 out of 100 Chinese families has a refrigerator, but China's ambition plan indicate that every home will have a refrigerator. So these are the facts. Ozone depletion, the Montreal Protocol. Research carried out by government and chemical companies for 15 years indicated that human-made chemicals were significantly damaging atmospheric ozone. The United States and an early leader banned CFCs in spray cans. CFC provided coolants for air conditioners and refrigerator, foams for industries, foam mattress and cleaners for electronic circuits. Evidence suggested that the most potent CFCs linger in the atmosphere for over 100 years, and that is a single chlorine ion from the breakdown of CFC molecule can destroy 1 lakh molecules of ozone. Discovery of a continent-size ozone hole over Antarctica in 1985 finally spurred governments into action. The result was unprecedented global cooperation on an environmental issue, culminating into the Montreal Protocol in 1987. The major achievement of the Montreal Protocol was to set target and dates to reduce the production of ozone depleting substances, that is ODS. It also extended financial assistance to the developing countries with annual OSD's consumption level of less than 0.3 kg per capita. Consequent to this effort, the ODS consumption level prevailing 1.58 million metric tons in 1988 was reduced to 0.63 million tons in 1994. The Global Environmental Support, that is GEF, which is a complement to the Montreal Protocol to ensure financial support and technical assistance to countries which are not covered by Montreal Protocol. GEF was set up in 1991 to facilitate global environmental cooperation between developed and developing countries. It is jointly implemented by the World Bank, the United Nations Development Programme and United Nations Environment Programme. The GEF has four priority objectives: reduction of the greenhouse gas load in the atmosphere, protection of biological diversity, protection of international water, and reduction of ozone layer duplication. The organizations also find that address land degradation, in particular deforestation and desertification, as they relate to the four principal focal areas. The Climate Change Convention. The Climate Change Convention was held at Rio Summit, that is the Earth Summit, in June 1992. The Convention Rio, which was held as a follow-up to Montreal Protocol, was signed by 150 countries of the World Bank's Global Environmental Facility (GEF), which operated during 1984 as the institution controlling the financial mechanism of the convention, was rejected, and Conference of the Parties decided to take that power to itself and establish the Global Biodiversity Conservation Fund, that is CBCF, to provide loans for projects which have environmental benefits in four areas: preserving the earth biological diversity and maintaining natural habitats, reducing and limiting emissions of greenhouse gases which cause global warming, arresting the pollution of international water, and protecting the ozone layer from further depletion. However, considering the extent of environmental degradation that had already taken place, greater efforts and cooperation from the international community is required to save the earth from destruction.